spent some time graphing a function I've given you an equation for, and now we're going to write the equation from the graph. So the first thing we're going to find is we're going to find the midline. So I'm trying to split this graph in half, and right now I'm seeing this. I'm seeing it's 3 below that line, 3 above that line. So that tells me that graph has a midline of y equals -2. So that means the whole thing's been shifted down two units from the x-axis. Another thing I can find because of this is since I see it's going up 3 and down 3, I know the amplitude equals 3. A couple things I'm seeing. I think this is a cosine graph that's been shifted around. If it was a sine graph, it would probably fall in a nice, neat number on one of the grid lines, and it's not. So I'm going to go with the cosine graph. So I see if I go with the cosine graph, I see it's been shifted right 1. The last thing I need to find is the period. I'm seeing the period is, let's see, that's 6 wide. So since I know the normal period for so the period is 6, and to find the b for my equation, since I know the normal period for a sine and cosine graph is 2 pi, I'm just going to take 2 pi divided by 6 and then simplify that, so I get pi over 3. So that's my b. This is my a. It's not reflected, so let's write this equation. So y equals, let's see, the amplitude is 3. It has been, let's see, it's a cosine graph, I said. The b number is pi over 3. It's been shifted right 1, so I got to put that inside the parentheses. And then the whole mess has been shifted down 2. So that, you could go check that out in Desmo, make sure I did that right. I'm pretty sure it is right. Sometimes it doesn't matter whether you use cosine or sine, and a lot of the pieces in here are very similar. So you're just going to take a look and see if it falls. If the graph falls in a nice neat line, one of those coordinate lines, those grid points, it doesn't matter. I mean, in fact, there could be many different names for this. I mean, I could say, instead of shifted right 1, I could have said this whole graph's been shifted right 7, and in which case I'd have a 7 in here, but everything else nicely stays the same. So just because when you look at my answers, I have one answer, doesn't mean that you're wrong. Okay? So here's another graph. Again, let's find that midline. Well, let's see. It's nicely hitting the x-axis, and then it's going all the way up here to 8, so that tells me halfway between there should be 4. So that the midline is y equals 4. I know the amplitude is also 4. And here's the situation where you see that graph is on the midline and it's at a grid intersection point. That tells me I can probably use a sine graph here. I could use a cosine, but you see how that is kind of like halfway in between, and I guess I could say it's been shifted right 3.5, but I don't know that for sure. I do know it's hitting at 1, at x equals 1. Alright, what else do I know? I guess I got to figure out the period out. Well, I'm seeing that this is 10 wide from where the time it goes up all the way back, down, and back. I didn't stress that on the first example. So the period is 10, and we're going to take 2 pi over 10, so the b number is pi over 5. We know the shift up, we know the period, we know the amplitude is 4. I think we're ready to rock and roll here. So y equals, amplitude is 4, sine, it's been shifted right 1. Oh, I know, let's see, the b number is pi over 5. It's been shifted right 1, and the whole mess has been shifted up 4. So that is the equation for that graph. So here's some exercises right out of 6.1, and this is number 5, so you can go look at the answers in the back of the book. I'm seeing, let's see, I'm seeing a midline right there. So that means the midline is y equals -4. I'm seeing an amplitude of 3. I'm seeing a nice sine graph. That's crossing nicely there. So the period is 2, right? Because this is 2 wide. So since the period is 2, we know that 2 pi divided by 2 will be pi, so that's the B number. We said amplitude was 3. I think we're ready to go. So y equals 3. And it's not been shifted left or right either, has it? It's right there on the y-axis, so that makes it nice. So 3 sine pi times x, and I don't have to worry about parentheses inside because it hasn't been shifted. The whole thing's been shifted up 4. Oh, down 4. I'm glad I caught that. I think that's good. Okay, for this one, I think that's the midline. 2 below it, 2 above it. Looks good. I see a cosine graph that hasn't been shifted left or right. That's good. I see a period of 4 pi. So 2 pi divided by 4 pi is 1/2. That's our B number. So I think we're good to go. So y equals, let's see, the amplitude was 2. Cosine, the B number is 1/2. It hasn't been shifted left or right. And the whole mess has been shifted up 1. Up 1. The last example, you're going to be glad that this isn't too long a video. So I think that's the midline. I see a cosine graph going on here because it doesn't look like the sine, it doesn't look like these points are crossing at the midline. So I still like a cosine. I see a period, that's a distance of 5. So 2 pi over 5 will be my B number. I see an amplitude of 2. It's not shifted left or right. I think we're good to go. So y equals 2 times the cosine. Oh, it's been reflected. Yes, so -2. Let me make that blue. -2 cosine of 2 pi over 5x plus 3. Right? I hope you're okay with the reflected part of it. I don't remember saying that for this video. Normally cosine starts up and goes down, and this is starting down and going up. So I know that's a reflection. I know a vertical reflection. A reflection around the horizontal line, y equals 3, right? Or around the x-axis, if you want to think about it that way. Okay? So that's the new stuff. You got some exercises to try. Let's get them done.